In the previous video, we were expressing volumes of solids generated by rotating them, or rotating a region around the line y equals c or x equals c. We left two problems and this one. Yeah, I forgot to put the function. Let's first do this one. Is the region between x equals 1, y equals enclosed by x equals 1, y equals 2, y equals 4, y equals the square of x minus 1, rotating it about x equals 1. And the other two would be the region enclosed by y equals minus 1, x equals 2, y equals square x minus 1, rotating it about y equals minus 1. And the other is the region enclosed by y equals sine x, the x-axis, and the left of x equals pi over 2, rotating it about x equals pi over 2. If you think you can do it, stop the video now and the next continue to see we have the same result. Alright, so here we are rotating it about x equals 1, so we need to put everything in terms of y. So let's put this function in y terms. So would be x is equal to square y plus 1. Now, one of the limits of integration, no, actually here we have both of them, both of the limits of integration from y equals 2 to y equals 4. If you want, you can check where are the points of intersection between this curve and this curve. It doesn't matter very much, but anyway. So we already have the bounds of integration. Now, we will take the volume will be pi r square or square r times dy. So will be the integral from 0 to 4 of, I can take the pi out. Now the radius would be, let's pick some number between 2 and 4, let's say 3. Substituting 3 here, we have y squared is 9 plus 1 is 10. And we have here x equals 1, so this is greater, so the radius is square y plus 1 minus 1, so it's just square y. So if we square the radius, we will have y to the 4th power dy. Alright, the last two problems are now this one we're rotating it about y equals minus 1, so all in terms of x. One of the limits of integration or the bounds of integration are x equals 2. The other will be when this function and this line intersects, so it's when y equals minus 1, so x is equal to 0. So this will be pi times the limit from 0 to 1, from 0 to 2 of, let's pick a number between 0 and 2, let's say 1. 1 square minus 1 is just 0, so y would be equal to 0, and here we have y equals to minus 1, so we will subtract this from this, so the radius is square x minus 1 minus minus 1, so plus 1, so this would be x squared. Now the area would be pi r squared, so pi times x to the 4th power. So here is pi times the integration from 0 to 2 of x to the 4th power dx. Dx is the width of each rectangle, of each disk. The other one, we are rotating it about x equals pi over 2. So we need to put everything in terms of y. So here we have sine x is the same as x equals sine to the minus 1 of y. One of the bounds of integration are the x-axis, so it's y equals 0. The other one would be when when the line x equals pi over 2 and y equals sine of x intersect. So this would be when here we substitute pi over 2 here, and we have y equals 1. So the other limit of integration is 1. So we have pi times the integration, or the defined integral, from it was from 0 to 1 of now the radius. Let's pick some number between 0 and 1. We have a 0.5. So what's 0.5? We have the arcsine of 0.5. Well, we know that the arcsine of 1 is pi over 2. So arcsine of 0.5 is something less than pi over 2. So that compared to pi over 2, this is greater. So we will subtract this from pi over 2. So it will be pi over 2 minus the arcsine of y, call this square times dy. Now you know how to find the volume of a solid generated by rotating a region around the non-coordinated axis without needing of the graph. But remember that always that you can graph, it's better you to do the graph. You need to know how to do these things algebraically, graphically, in any way. That's the consequence of Leibniz.